Hello, chemistry. Hope you're having a wonderful day. Today, our topic is 11.2, qualitative description of gases. This is my first day on the mic. If you guys have any suggestions, if it's not loud enough, let me know. I'll bump up the volume. I will be putting these out. I emailed Brewster. I'll be putting these out every day as much as I can to kind of give you guys some instructions so you guys aren't trying to just work through this by yourself. This is for day 2, so if you want to take notes on this PowerPoint instead of from your book, feel more than welcome. So remember the difference between quantitative and qualitative. You guys remember that quantitative is anything that has a number value. I have a balloon, it has 2.4 moles of nitrogen in it. That has a certain weight, which I can calculate. Qualitative is much broader. I have a balloon, and I know that it has oxygen, carbon dioxide, and nitrogen gas inside of it. I don't know how much. I just know that it has it in there. It's good. It's data, but it just doesn't tell you a lot about your data. To know how much air is inside an object, you need to know volume, pressure, temperature, and the quantity or number of molecules. If you know any 3 values, of course, you can calculate the 4th one. We're going to be using some algebra starting in 11.3 to do just this. But today is just, we're going to talk about why gas behaves the way it does. Pressure and volume. Pressure is the amount of the pressure a gas exerts, in a container is caused by molecules moving and hitting the walls of the container. So over on the side here, you see that as that piston goes back up, they're hitting the walls a lot less. But as it compresses back down, you see a lot more molecules hitting the wall. So the pressure is going up. This is what happens. Same amount of gas in a smaller container, more times they're hitting the wall, more pressure. Temperature and volume of gases at constant pressure. So what happens if we keep our pressure constant? When your temperature goes up, the volume has to increase for pressure to remain constant. So if your temperature goes up, you're moving faster, they need to have more room to run around in so that the pressure remains the same. At higher temperatures, they move faster, they collide more frequently. If you increase your volume, they're further away, so they won't hit the walls of the container as often. If you decrease your temperature, on the other hand, if you go the other way, you slow this gas down and it collides with less force less often. So if you're in a very big container, it will hit the walls not a lot. But what happens if you shrink that container down? If you decrease the volume, then the gas still collides at the same rate as that higher temperature, and this keeps your pressure constant. Pressure and temperature. Temperature is the average kinetic energy of a gas's molecules. We talked about this in 11.1. So the higher the temperature, the more kinetic energy. So also, moving faster, the higher the temperature, more collisions. It's hitting the walls of the container more often. The volume of the same number of molecules remains constant with a temperature increase. You still have the same amount of volume, but now it's under a lot more pressure, because the same amount of molecules have more energy in the same space. So they're hitting the walls more often. Pressure is just how often they hit the walls, how much force is being exerted against the sides of your containers. If you have a gas cylinder that's empty, it's not a lot of pressure. But if you have one that's all the way full, you have a lot of pressure. And if you overfill it, you could possibly have enough pressure to pop that gas cylinder open. Pressure in moles. At a given temperature and volume, the number of collisions with the container wall relies on the number of molecules present. If you're not increasing your temperature and you're not decreasing or increasing your volume, it makes sense if you have more molecules, more individual particles, then you're going to have more collisions, just because there's more of them. More molecules equals more collisions within a given time frame. More collisions, more pressure. So if you have more moles, you have higher pressure. The more gas you're spitting into something, the higher your pressure. It makes sense. Don't get caught up in the language. Just sit down and think about it. If I have, only a few moles, I'm going to have very little pressure. I don't have a lot of gas. Relationship between volume and moles. Volume depends on the temperature, the pressure, and the number of molecules present. If you keep your temperature and pressure constant, then the volume directly ties to the number of moles. Number of molecules increases, number of collisions would increase, and your volume would increase. You have more of a gas because you have a higher number of molecules. So, for 11.2 review, which is questions 1 and 2. If you turn it in before the end of the day Monday, take a picture of it and send it to me. I will give you +5 on your participation grade. Kind of a little Happy Friday gift. Hope you guys are doing well, and as always, stay safe and stay healthy. Talk to you guys later. If you have any questions over the weekend, I will be checking my email once daily at least. Have a good weekend.